it's just going to be a very quick recap, because the idea today was actually to give you exercises for you to give me the answers to. We explained a transverse waves, ladies and gentlemen, as a wave in which the disturbance is at right angles to the direction of propagation. The only difference between the wave and the pulse is a single disturbance. A wave is a regular succession of the pulse. Succession meaning one pulse after the other. So 1, 2, 3, 4, 5 pulses, they actually form a nice wave. So you have your pulse number 1, pulse number 2 combined, ladies and gentlemen, they produce now what is a wave. So a wave is just a disturbance at right angles. However, it is now a regular succession of the pulse. So you must have your pulse in order for you to actually generate a wave. But you don't only need one pulse, you need a multiple number of pulses. Ladies and gentlemen, we tried to explain what is a wave in terms of positive identification, in terms of the labels that we need, in terms of identifying the wavelength, the amplitude, and all other things that has to do with this particular wave. Why do we need all this? Ladies and gentlemen, for the purpose of calculations, we are going to need to identify the period, we are going to need to identify the wavelength, we are basically just going to need to identify most of the things here. We explained the crest as the highest peak. As the highest peak of the wave, and crest trough now as the lowest point on the wave. However, we said for us to determine the wavelength, the distance between the two successive points that are in phase. So for me to talk of a wave length, it must be the distance between two successive points in phase. Successive points means what? When I look at E and H as the 2 points that are in phase, how can we tell is 2 points that are in phase? Because 2 points on a wave that move in the same direction at the same speed and have the same displacement. Hence, when I started engaging with you in terms of points in out of phase and out of phase, I said this is a critical, now what? A critical concept, because we are going to need it. So points that are moving in the same direction and have now the same displacement, very, very, very important. Then we will be able to identify our wavelength. Ladies and gentlemen, that is now the wave, and we did an exercise where we identify which point is the crest, trough, amplitude, position of rest, and so forth and so forth. So understanding this example allows us now to interpret what is frequency and what is the period. We said frequency, it is the number of waves per time. The symbol is smaller than a f, and then the SI unit is called hertz with HZ, capital letter H, very, very, very important. The period is defined as the time taken for one wave to complete, for one complete wave. So it's basically the time taken. Symbol T, SI unit seconds, but we just use a symbol of S there. Ladies and gentlemen, we did an example of how to calculate the frequency, on how to calculate the period. We went into calculating the wavelength, where we said the wavelength is the distance that one wave covers in 1 second. It is measured in meters and the symbol is lambda. And the equation is given, ladies and gentlemen. V is equals to now F multiplied by lambda. We had an example of that, of which is part of the e-notes that you already have. Ladies and gentlemen, I have question number 1 and number 2. This is now for us to actually discuss. We will do 1 and 2 together. The reason why we do 1 and 2 together is I just want to assist you in terms of how we can go about this one. Ladies and gentlemen, it is very easy. The best thing to do is to write down the data that is given. So I'm going to write my data and check the information that is given. Ladies and gentlemen, a water wave comes into the harbor at a speed of 1.5 and a wavelength of 200 centimeters. Now let's write the data that we have. Calculate the frequency at which the wave hits the harbor. We are given V, which is the speed, 1.5 meters per second. We are given lambda, which is 200 centimeters. What is the question? They want us to calculate the frequency. But we have a problem now. What is the problem? The problem is now our lambda is in centimeters. We want it now to be in meters. So the question is, how do we convert Katleho from centimeter to meter?
So I think we have to multiply. No, actually, so we have to divide. Sorry.
Thank you. We divide, but with how much? Or with what factor?
So we have to divide by 100.
Thank you very much. We divide by 100. Remember, these are now critical conversions. If you don't get the conversion right, automatically now everything will collapse. Ladies and gentlemen, we then write the formula as it appears in the formula sheet. 1.5 F is the question, and then multiply by 2. Divided by 2, divided by 2, we get now F is equals to something like 0.75 hertz. And it becomes now nice and easy for us to actually understand. Why? Very easy. Data that was written. And now at number 2, 5 waves cover a distance of 10 centimeters in 10 seconds. Calculate the speed of the waves. Let's write down the data. The distance that is given, D, is just 10 centimeters. Already divided by 100, 0.1 meter. T is given now as what? As 2 seconds. What are they asking us? They are asking us for V, which is now the speed. How is it easy? We just write the formula. V is equals to D over T. Then this is just 0.1 divided by 2 seconds. You get your answer, which is 0.005. Let me check. 0.05 meters per second with the correct SI unit, and we will be able to say this is now 100% correct. Ladies and gentlemen, these are basic questions that you will get in grade 10. However, questions will come differently. Hence, I am going to give you now this one. And we are going to do this one for the next 15 minutes. and please send your answers. We are going to do this one for 15 minutes. I'm going to be quiet also. 15 minutes means exactly at 8 o'clock. Then we can push until 8:15 in order for us to explain this. Please, ladies and gentlemen, send your answers exactly at 8 o'clock. Ladies and gentlemen, thank you very much for your answers. However, we did not get it right. And the only reason why we did not get it right is because of not understanding and reading the wave. Yes, we did not interpret the wave that was given. And at the very same time, we did not use the concepts to actually understand what is happening. Let's start. Allow me to take a highlighter to say this is now wave number 1. Let's take a different pen. This is now wave number 2. It should actually be this way. 1, 2, 3, and something like 4. Now let's check the definition of what is a wavelength. Wavelength, we defined it as the distance between two successive points. 2. But when you look here, we are going to have point 1, let me call it A, B, C. So ABC is not a wavelength because it is not 2 points that are successive to one another. However, AB is a wavelength. BC is now another wavelength. So this basically says here I must have 30 centimeters and here I must have now 30 centimeters. So that is now me understanding the wavelength. So the wavelength is 2 successive points, not 3. So we did not apply the concept of the definition of what is a wave. Do you understand, Katlewame? Do you understand, Letabo?
Yes, sir.
Thank you very much. Because honestly, the definition of a wavelength is 2 successive points that are in phase with each other. So here we are given ABC, which is now 3 points. So for us to be talking of wavelength, it should only be 2. So our wavelength is actually equals to 30 centimeters. That is now at 3.1. So lambda is equals to 30 centimeters. And 30 centimeters divided by 100, it will give us 0.3. So lambda is equals to 30 centimeters, which is equals to 0.3 meters. And because of an incorrect wavelength, ladies and gentlemen, everything now becomes incorrect. Why is it becoming incorrect? Because now let's check the question. Calculate the wave speed if the frequency is that. V is equals to F lambda 4 multiplied by 0.3. So you are going to use multiply by 0.6. And the 0.6 is now incorrect, unfortunately. So it means everything now is collapsing. Hence, when I check your numbers, the only thing that I looked into was easy, was just to check if you got the wavelength correct. Because if the wavelength is correct, everything now becomes nice and easy. To calculate the period, T is equals to 1 over F. What is frequency? We are told the frequency is 4. 1 over 4, and the final answer here is 0.25 seconds. And the answer here is 1.2 meters per second. That's how easy it gets. But the fact that we did not apply the concept of what is a wavelength, everything, ladies and gentlemen, collapsed. Everything, we did not now get it right. So remember, definitions are critical in order to support and assist you in terms of identifying and understanding the questions that the examiners might have. At number 4, very easy also, the vibration of a generator produces a transverse waves to it. The waves moves at the cable with V, which is equals to 8. If the wavelength is 200 millimeters, calculate the frequency. Very easy. V F lambda, this is just 8 F multiplied by 0.2, because remember we are going to divide here by 1,000, divide by 1,000, and then we get something like F is equals to 40 hertz. That's how simple it gets, provided, ladies and gentlemen, we understand how the wave basically operates. Let's inputs, please, and reflections of today.
No, sir, I have nothing. I now understood where I got it wrong.
Thank you very much. So remember, the definitions are a tool that you must use in order to understand complex questions, because this examiner was not being funny. He was just testing the skill that we understand what is a definition of a wavelength. Katleho, reflections, please.
So apologies for earlier. I was having trouble with my laptop.
No
But
problem.
so I understand now where I got it wrong. I think I won't make the same mistake next time.
Thank you very much. Ladies and gentlemen, it is exactly 20:09 from me to you. Let's meet again tomorrow at exactly 19:30. However, I'm going to give you this exercise number 5 for you to actually look into it. Please submit before the class. It is an activity that we will do under wave, sound, and light, and then we can move now to other different concepts. With that being said, ladies and gentlemen, thank you very much. Expect me to send you the e-notes as soon as we are done here. Thank you very much and have a lovely day.
Bye, sir. Thank you, sir.